Okay, I've begun our recording and I will begin to start going through the content for today. Thank you very much, everyone who's joined us. My name is William Ward. I'm the New South Wales Manager with PCTE. I've created today's content in partnership with Hugh James, who works out of Victoria, but is our National Ground Penetrating Radar Manager, both on the subsurface surface utility location side of things, along on the concrete scanning uh, radar side of things. His background is as a surveyor, so he spent a lot more time out on site collecting data and providing input back to customers. So a lot of the content I discuss about visiting site and working on site is directly from Hugh's brain. And I'm sort of providing a bit more context around the specifics of non-destructive testing equipment, primarily for concrete, as that's more of my background at PCTE. As I said, if you do have any questions as we go forward, I've got the group chat in front of me, so text questions are fine. I'll also periodically stop and ask if anyone would like any more information. And when I do that, I should be able to pause and answer those questions briefly. I am recording the presentation. I will send a wrapped up version where it'll be only lightly edited, just removing any conversation that's stray from the topic during our time together. I'm planning to finish up no later than 1:30 today, but I think with the content I've got, we should be through in 40 or 50 minutes and have time for any questions and answers at the end as well. But please ask questions along the way. It's better to go and discuss things in context. So today's topic is about preparing, collecting, reporting NDT site data. I'm going to begin by talking about what to consider before you go out on site. What do you need to prepare? And is there anything you can do prior to preparing to make sure that you have a successful time on site? For the discussion about being on site, we'll talk about preparing your workspace, and also because this is the point where you're probably configuring the data logging functionalities of your hardware, I'm going to go into quite a bit of detail on the different grid-based data logging functionality of your GPR systems, your impact echo systems, and your ultrasonic systems to understand that while it's all grid-shaped data, it will all be a slightly different type of grid, and it would be helpful to prepare your markup grid on site a little differently and have a good understanding how each of those interacts. Then we'll talk about leaving site, making sure that you've got the best chance to be finished and ready to go before you go out, and then go through some of the data output functionality from both Screedy Eagle and Defelsco, who are the two suppliers that we work with at PCTE who have the richest data logging functionalities, the richest output functionalities. I'll also go back and show a few examples I previously presented in other webinars, or my colleagues and partners out at Screedy Eagle have presented about some of the work that they've done with the data after the fact. So before site, we need to know what equipment we want to be using, where it is and what condition it's in. So I'm going to talk about keeping a record of that equipment, auditing and why that's important, and then prepping it for site and making sure we're bringing everything with us that we might need to be well informed and able to work correctly while we're working there. So at PCTE, we've got a lot of different non-destructive testing equipment, ground penetrating radar equipment, lots of bits and pieces in different offices and different locations we need to keep an eye on and to know that it's well maintained and healthy. We use a couple of different tools to do that. We have an equipment register, which tracks the condition, some records such as serial numbers. I've removed them from the example here. This is a much cut down just to show the basic principle, and also a procedure we use about when to check equipment and who's responsible for doing so. So with the equipment register, we have used Trello, which is a Kanban style card setup. If you've never seen this kind of thing before, it's essentially recreating index cards pinned up on a board, moving between locations, originally used in Japan as part of a very manual way of recording information, such as parts and production through a production process. And it's come out these days in these Kanban style systems you've probably seen before if you use that kind of software. In particular, in our Trello cards, we keep a bit of information about the devices, when they were purchased, serial numbers and other information, visual records of their content. But the most important things are a checklist of the contents. So anyone who receives that equipment can see what should be there and confirm it's there, and also an activity record. So when people make the check, they can let them know that this was completely present and healthy on Wednesday the 23rd, say. We also, because we can move these cards around, we can put them in the particular office that they're in. So that's the rough way we track our equipment register. Now, this is not particularly sophisticated. There are softwares for managing fleets of equipment. And if we were running a larger organization where we had many vehicles and hundreds of thousands or millions of dollars of equipment moving, that register system becomes much more important. But this is something manageable for the scale of what we're doing. So on the process side, we've decided that anyone who's receiving equipment, dispatching to a customer or to another office, or has used that equipment will need to perform a check. And that'll include going to the checklist, making sure it operates, charging before it's put away or before it's sent out, and also giving things a clean. Now, this is quite a bit to track, and it's a manual process, so we don't know if it's wrong. So the important thing, wherever you've got a register or some form of record that isn't automated, doesn't update itself, is you do want an audit step. I personally use for my task lists at work, getting things done, and that's quite a structured process of capturing what those tasks are, organizing them by project, all that sort of detail. Not very important for the scope of this, but the most important thing I ever learned from using this task tracking process is the review stage, which means that if we want to use a reasonably involved, detailed list of items or tasks, or in this case, testing equipment, we're going to want a review stage. So the review stage for records like this would be, when was it last updated? And if that last update is too far distant, to repeat the check. Is it accurate? Does the information inside the register match the physical item and include everything? And also, if there's anything that shouldn't be there, it gets removed and put elsewhere. The idea is that when an audit check is complete, it should be complete, either 100% of everything in the register checked or 100% of categories. And that wouldn't be by office, say, because things could move around and get lost. It would be more by product type. So maybe all the GPRs are checked on one audit, then all of the non-destructive concrete testing equipment on the next, metal testing equipment on the next, and then maybe samples of instrumentation the other time. And it's important that the same person does this, and that someone who's familiar enough with what your organization has, that they know if something's missing or if there's something new or anything like that that's going to help provide that context while doing that check. If it's just someone who can't tell a Schmidt hammer from a cover meter from a radar, they're not going to be able to know what's missing, what should be there, or how it should look or how it should work. So do make sure, even if they're not part of the site team or using the instruments, they know enough that they can give them a check and know what should be there. Now, before getting out on site, charging can get really a sort of a continuing irritation with equipment like this. You've got rechargeable batteries in some devices. In other devices, you've got batteries that should be replaced, like an alkaline battery. You've got different kinds of battery technology, maybe lithium, maybe nickel metal hydride. And you've often got multiple battery packs so you can get a day of productivity out of a system. You've got to manage all of this in a way that you actually know the state of equipment. So you only want to charge rechargeable batteries. It's critical not to charge anything which is not able to be recharged, because if you do, that can cause damage or even a fire. You also want to use good quality lithium batteries, again, to prevent that risk of fire. Typically, the best time to charge is right after you've used it, because then it will be available next time you need it, even if that's very soon or unplanned. And you do want to do a final check that everything's ready before you use it, because batteries will discharge over time, and some devices will have a natural discharge cycle where even when they're off, they're asleep and they're slowly running down their batteries. If you've got multiple battery packs, it's important to separate them in charged and uncharged. And if it's consumables, it's better to have a spare than to check it, because the battery life representation you see inside an application or on the screen of a device, while it's an indication of the battery, it can stay high for quite a while because it just is based upon the voltage happening internally. So it's better to know it was charged than to know the device reports it as charged. This is also a good time to restock any consumables and check them, combine orphan sets. And again, particularly because we do have those different kinds of battery, the particular process we use at PCTE is we'll charge anything with an embedded or lithium-ion battery every time we do a check. If it's a nickel metal hydride battery, they do actually have what's called a memory effect, where if you charge nickel metal hydride batteries before they've been discharged, they can slowly degrade. So it's better to have a fully charged spare battery in the kit than it is to recharge the batteries. And if it's a single-use battery, once again, we want to have that spare available. Now, if we're going to go out on site, what do we need? Well, we sort of need to know what we'll be doing on site. And there's a couple of different sides to that. The first thing is what our client actually wants the output to be. And sometimes clients can be very non-specific, asking for, oh, we need to have ultrasonic pulse velocity testing done, or Schmidt hammer testing done, or radar scanning done, or concrete scanning done. And that's not really enough information to know exactly what they want back from the day. If it was concrete scanning, it could be a full set of data exported, annotated, marked up and provided, or just as likely, it could simply be a set of marks on the ground showing the position of embedded services and reinforcing and post-tensioning and other information, perhaps with a secondary report showing the markings, where they were taken, just with a bit of record keeping so they know when it was done and what was found at that time. Going beyond that, there may be particular data formats people want out if they're going to be post-processing that data. I know that we've done some work recently with the GS9000 radar to collect some very specific geographically referenced data to combine with laser scanning. So we had to have aluminium markings on the ground to pass over as a fixed point, survey points taken off with satellite positioning on the radar, so that when the laser scanner was used, it could mate its information up with those same spots. So do know that the more complex the output, there's going to be some preparation so it can all be put together at the end of the project. You'll also need to know what kind of report they want out. So PDF formats, or perhaps a more specific data format that they use in the internal asset register. In terms of documentation for your organization, it's good if you do the job multiple times to have a procedure and methodology so that everyone's doing that the same way with the same annotation and information, so that when you work together on a job, or someone needs to go and do a job someone else was doing, they're both working in the same way. And there might be multiple methodologies, even for something like radar scanning, depending upon the output the client needs. It's also a good time to gather any site information you have and any safety documents internal to your organization, or which will be required by the client before heading out. A particular, just a useful thing to have is to know exactly what you're taking. So before you head out, you can check it's all there before you head back. And that's not just the NDT equipment, that's everything down to the notebook and pencil and the chalk line. So you're not missing anything you'll need and have to go and get it. And when you leave, it's not waiting there previously. So on site, a couple of things to consider. You need a way to know where you have been. It's also, as much as possible, very helpful to clean up and set up before beginning work. I do understand in live construction sites, there can be a lot of things going on at the same place and you may not have a lot of capacity, but the tidier you are in setting up, the tidier you will be going forward. And data logging is the same. If you just turn the device on, start recording information, you won't have the same context as if you chose and followed a structured way of naming your files, naming your records and setting up your grids and other information so that it'll be more meaningful at the conclusion of the project. It's also a good point to start thinking about redundant data. Yes, you're on site. Yes, time is money, but it's much better to have multiple copies of some critical records, or to combine tools like multiple forms of non-destructive testing, which have the same sensitivities. So if you do that, it maybe prevents need for more site work later if you've got the information you need now. So where will you be collecting data? You should already have an idea based upon the client's requirements before you get there. Maybe you've got some rough sketches or annotations. Maybe you've got some drawings. You'll be able to mate all that up depending upon a way to name it. So that might be something like chainage, distance along a path, or column 1, column 2, column 3, column 4, or names for particular locations. It could be sketches on grids. If you are going to want to represent information on drawings or sketches, and even if it's semi-critical, you will want to have references back to fixed locations, ideally at least 2, so you know how far from the wall, how far in you are. The more precise the client's needs, the more careful this information will need to be. It's also good to know the kinds of NDT data that you'll be producing. Are you with radar doing only simple scans for information, or are you doing grid scans to present more of a 3D view? If it's a Schmidt-Hammer, what configuration of Schmidt-Hammer settings, how much information each time, everything written up. Finally, when you are picking locations and you're choosing points to reference, it's better they don't take that wall out or cover up areas that you've referenced from if you're ever going to come back and find the same locations. This might also be the time where you start to put some annotations and marks on the ground, if you're able to do so, before you begin collecting data, particularly around grids or locations for things like Schmidt-Hammer testing. So you've got a set of areas to work in with their names and things already configured. Now, some equipment can be damaged if you're moving it to, if you've got grit on the ground, something like a waterproofing membrane with a lot of construction dust could damage a waterproofing thickness gauge. You don't want to be scuffing any equipment if you can avoid it. So do clean and tidy as much as possible. If things are in the way, get them out of the way so you can access the full site. And also, ideally, lay out your note-taking and record-keeping equipment, get your radar in place, be ready to work. Don't sort of be working out of a bag with everything a mess together. Now, this video that's going to start playing is about setting up ground penetrating radar data. If you just jump in on a ProSec radar, yes, it'll give you a file name. Yes, you'll be able to start scanning, but that's not all the information you can set up. And you can take a little bit more time, go into the data structure, set up a folder for the project. Inside that folder, make a new file, choose your file name based upon what you would like to do in that area. Maybe it's location tracking, maybe it's just a particular kind of data. Adjust all of your settings. So if you're going to be doing an area scan or a line scan, now's the time to choose to do that. The repetition rate is set at the time of data collection as well. That's how much data you take per distance the antenna's moved. So we've chosen 0.5 centimetre here, 5 millimetres. And then you'd begin to start, then at least you're sort of set up and ready to go. If you're doing a grid, we have 2 choices for grid sizing here, a 5 centimetre or 10 centimetre spacing. And you can also either define precisely the size of the grid by holding down on that arrow symbol there at the top right corner, or if you would prefer, you can drag it left and right and shape it that way. So grid setup, file name, measuring presets in place for a ground penetrating radar. And we can see that if we double tap that top right corner, we go back to the default, which is a 600 millimeter by 600 millimeter, 60 centimeter by 60 centimeter standard grid. It matches the grid that's in the case of your radar, except for the GP 8100. You can also put in any presets, any visualization settings at this point to really get everything where you want to be for the rest of the project. if you start a scan from, so if we finish this file and start a new scan, all the settings in place will move over to the new scan. If we were to go into a different file and start a scan from there, the settings would come from there. So it's important to always start from the same place. Once we've got our data, we can also take some more information. So we can take photographs. If you are taking photographs, take one close up showing the details, and then back up and take another photograph that shows that position in context. I'm just my office floor here, but the idea is that we can see what we've done and where it was done, and then you'd have this reference back in a little bit more detail. We can also add, at this point, text comments. We can add annotations to our GPR data. The annotations to be positioned, and we can also store information as a text comment on each annotation. We could enter a diameter size if we know that from destructive investigation. And if we'd like, we can actually set the depth. But if you set the depth inside the radar applications, it will also adjust the dielectric constant, which is used to calculate depths of every target inside that scan. So be aware, if you're using the set depth, you're actually doing a process of setting up the dielectric constant for your GPR data. And it's going to be similar on any instrument you use. There's going to be presets, gains, adjustments you can make as you go. Now, going into a little bit more detail about different grids, I've got, it all looks relatively similar from the top level, but each device you use is going to have its own rules for operation. For ProSec radar, the GP8000 or GP8800, you will use single lines of data in a lateral and longitudinal direction, which is going to give us a 3D block of data. In particular, we set up the grid size and then we scan along each line at 10 or 5 centimeter spacings. And as we take each individual line scan, they're combined by the software to produce the 3D representation. For the GP8100 radar, things are a little bit different. Rather than collecting data the same way as we would on a single antenna, there are 6 antennas inside each device. So we'll pass it over swathes of 30 centimeters, collecting 6 lines of data in that direction. And that lets us collect a 3D data much more quickly, but we will still need to do the x-axis and y-axis directions to produce the full 3D block of data. If you look at the included map that's included with the GP8100, it has lines at that 30 centimeter spacing. The other thing is, if you look at the visual representation of spacing, you see that the 0 point on that data is not given at the origin. They define 0 as the first line, and then that 30 and 60 centimeter spacing along for each data collection point. So that's why I've highlighted that we're collecting not at the origin, but starting 15 centimeters into the data set. This is an example of how we collect data for the PM8000 cover meter. That's this device here. It is the lot used with the PM8000 Pro, where we have a wheeled car that lets our cover meter know the distance it's traveled and produce a set of gridded data. Multi-line scan is specifically intended to collect information where you have individual grid positions where we care about the closest part of the surface in each position. Something like if we were to compare our data to half cell potential data or some other format of spot grid data, which I'll talk about in a second. The critical thing to understand here is they do start measurement at the origin, but they only collect data in one direction, but they're only measuring depth of the reinforcing as close to the top surface. And then its grid boxes are defined based upon a spacing you put in. So I've put a 20 centimeter spacing in this case, giving me 20 centimeter boxes with the lower box cut in half because of the way data is collected. Now, all of those machines, we're rolling them over a distance to collect information. A lot of other non-destructive tests are discrete. We take information in a particular spot, like impact echo testing, ultrasonic pulse echo testing, or half cell potential results, which are taken without a wheel electrode. So for these spot grids, particularly in the ProSec applications, they'll define them as a numeric code with a alpha on one axis, numeral on the other. But we do have the ability to change our settings over in our grid dimensions to show the physical position of each box. But we've divided the grid into cells. So the actual data collection point is 5 centimeters, 10 centimeters, 50 centimeters in. We don't start at the origin. And if we're comparing other data, we need to understand that we didn't start at the origin. And it's not just ProSec instruments that work this way. Similarly, this is the Concrete Thickness Gauge 2 software from Molson Instruments. In this case, we do have the ability to collect data on a grid, but we don't have a visualization of that grid. We need to understand what we're doing. So I've drawn up that in this case, there's a 30 centimeter space between measurements. So 0.3, 0.6, 0.9 in each direction. And we'll need to manually adjust our X and Y position to move between if we need to. So this is the kind, so if you've got software where you maybe don't have visualization in the application and you'll be using it for the first time on site, I do recommend taking a couple of hours, just doing some mock-up projects until you know exactly how to use the settings menu, that when you export the data and produce a diagram, it's going to come out the way you expect it to. Finally, I wanted to highlight some of the different data formats that you can collect with the PD8050 ultrasonic pulse echo device, because this has a grid scan mode, which is just that kind of spot grid I showed previously with the pundit impact data. But we also have its line scan is actually collected by pressing the probe on the concrete face and then moving it sideways a certain distance each time. So it's effectively a one-dimensional grid. And similarly, its 3D data format is collected the same way, placing the probe onto the surface and moving it forward a particular distance. But in this case, it's going forward rather than sideways. So you will need either to have that sketched up on site ready to collect, or there is the tape that can interact with the camera inside the device that will tell it how far left and right or forward and back the probe is positioned, and remove the need for that markup on site previously. Both are valid ways to collect that data. The grid measurement is used the same as any other grid measurement. Now, a quick word on redundancy. It's much easier to collect more than one measurement on site today than it is to go back tomorrow. So if you're doing something like Schmidt-Hammer testing, it's better to have a lot of tests than to take half an hour and have only a couple. You also have the advantage, the larger and larger your data sets become, you start to be able to confirm consistency, and you start to be able to confirm, is your data repeatable? If your data is repeatable, that's very useful to know, because it means that it is likely that the controlling input to that sensor is what you're placing it on. So if you can do something like an impact echo measurement and take off the measured thickness, say 150 millimeters on a slab, and everywhere you test on that slab is 150 millimeters, gives you a bit of confidence that the data is repeatable. And if that thickness was to change, you could consider whether that change is due to a change in thickness, presence of a defect. And if that machine was to stop measuring accurately in a region, that's another reason you could look at that and go, maybe that's where my problem is, where the issue I'm on site to detect is occurring. So the more data we have, the more we can compare it in itself for consistency, either around confidence or around looking for the anomalies. Certain kinds of technique can be paired together. Schmidt-Hammer and ultrasound have been combined into Rev Ultra because they both have a relationship to material strengths. I really like contrasting ultrasonic pulse echo and impact echo data together because they're both seismic techniques. They're both used to visualize the potential defects inside an element. So if I've got data that allows me to essentially go, my ultrasonic pulse echo device detected something unusual here, and my impact echo test also varied in that area, I start to feel a lot more confident about raising a question than with one non-destructive test alone. Particularly useful if you're limited in how much destructive testing you can do on site, which is a terrible constraint. It's always better, regardless of what non-destructive tool you use, to have some scope for destructive testing. But one of the tools we have to reduce the amount of destructive testing we might need to do is to compare tests of similar sensitivity. It's also good for things to combine information like cover meter data and radar data together. Cover meter data is more precise for depth accuracy. Radar data can see more information, has a greater depth, and can see multiple layers of reinforcing. So there's benefits to each tool, even if they have a loosely similar sensitivity. Now, some tests, like the video that's playing on the right, actually have repetition as part of their data collection. So sonic echo testing, like a pile test, impact echo testing, a lot of the discrete point tests using sound or seismic energy will repeat the test for consistency. And you can see here on a large pile, you actually repeat the test with the sensor placed in different locations on that pile so that you can compare several impacts, which is the trigger for the data to be collected, to a secondary and tertiary test on the same pile, which should all report same rough depth information, same rough waveform input. And some of the Schmidt-Hammer tests certainly collect multiple impacts just to do statistical processes, sort of average the data, remove outliers, information like that. And finally, before you finish up on site, it's always worthwhile, make sure the job is done. If the client had a particular output they required, can it be given at this point, or is there something missing? If you've got location information you were collecting, go and do a quick double check. Are all files named correctly? Are all, if you've got a particular way you're referring to that column or this area, is that recorded? If you're using a visual tool for placing information in context, is everything placed in the right place? Does anything need to be adjusted? Quick double check of location information. Make sure everything goes back in the car. If you've taken a list of what's going out, you can use the same list to pack back in. And make sure everything's backed up. If you've got a device that has a synchronization function, I've shown one of the Screening Eagle applications on the right here, make sure everything is synchronized. If you've got handwritten notes or some record like that, take a photograph, do something so if it does get written on, rained on, dog eats it, you've got a record. And if you're using a machine that doesn't have an internet connection, you can take a second backup on a USB drive or use a cloud tool like Dropbox to synchronize that data before you leave site where possible, or as soon as you've got the ability to let data synchronize. It's always harder to go back and get it. Better to make sure it's there at the time of collection. Now, for different devices, we export data with Screening Eagle devices from their workspace application. That was what I quickly showed a little bit of the export functionality inside the iOS application for the GPR, the iPad OS application for the GPR. That export functionality does run through the workspace website, even if we're just sending files from one iPad to another. And Defelsco has like a surprisingly large number of ways to move data around. So I'll mention each of those and some of the capabilities you have when using one of the Defelsco POS detector devices for waterproofing membrane thickness, coating thicknesses, or other measurements. And I've got to say, I've just taken a couple of examples of what we can do with raw data once we're done. You may have seen these before, but they're just to sort of wrap up the conversation. So with Screaming Eagle, the first output we have is the sharing, which I will quickly demonstrate again. what kind of sharing we have available inside a tablet. At this point, if someone could just quickly unmute and let me know that my iPad screen is visible, because this does remove my preview on my webinar. So is my iPad now visible?
Yes.
Excellent. Thank you very much. So this is the GP application, but the export is going to be loosely similar on most ProSec NDT device application. And if we enter a particular file, the first thing to understand is that if we've got a visual that we want, a picture of a particular view of the data, let's say I want the migrated data here without the annotations visible, I can use the save snapshot or export snapshot function. If I export a snapshot, it's going to open up the iPad OS export. So I can email this to someone, text message it, share it across to my computer if my computer is a Mac or another Apple tablet, save it into the file system. Lots of ways to work with that if I would like. Now, this is the quickest way to get a picture off, but it only works once. It is better to use the save snapshot functionality, which will record in that logbook for this device that picture. So see, we have the snapshot that was exported. That lets us know we did that, but the save snapshot is now stored inside that. If we did want to further export that to someone, we could do it from here, but it's also going to give us access to that information back on the computer when we return from site, provided that data is synchronized. So we can see that that small green box is going to fill up, and now those snapshots are back on the web service for me to use. The other export functions I have, export a segy is raw data. So if you would like to manually load this data in post-processing software, the segy export is what you need to use in third-party applications or to use inside GPO insights if you want to bring it in manually. You'd normally do it through Workspace. That segy export does require that your data is already synchronized. So you won't be able to complete a segy export until your data's had a moment to sync. The export as HTML is a way to send the logbook information to a user. So I'm going to send this across to the computer I'm working on. I'll show you what that export looks like. So I need to close my screen share here, and I will be able to bring up the output from that. And this is the logbook, so I can have a look inside, and I've got that picture I took as a snapshot. I've got the annotation information. I've got the distance that I scanned, and I've got the records that it kept. You'll notice that I do have this exported snapshot, but it's not saved up here as a snapshot separately. Share as URL. That was share via URL. This is specifically to pass a duplicate of the radar record across to another account of the GP application. So over here, we have my user logged in with my company email. If I want to send it to one of my co-workers, share via URL will allow me to send a duplicate. I could also do bulk exports of different data formats. So if I want all of the segy data, all of the scans just in a version that a customer could open, or with the snapshots visible, or all of that data duplicated in a different account, I have that access from the top screen here. Further to this, if I go to workspace.screeningeagle.com, this is where all of the synchronized data from my ProSec devices is going to end up. So we can see that most recently modified data. is going to be what I was working on here, including the snapshot saved. You can open up in a new tab. We can export the segue data from here as well, and also share that between users from here as well. So I've got a lot of the similar export functionality I have on the iPad application elsewhere. Now, I don't currently have a GPR Insight account, but this is also where I could access GPR Insight's post-processing software to use this GPR data separately. And I'm going to have all of my different kinds of data available here. If I've got Schmidt-Hammer measurements, they will be recorded and exportable from here in the various available formats. So, for example, you can do PDF exports or CSV files for different kinds of Schmidt-Hammer data results in here. Now, if you are going to be opening up CSV data inside Excel, I do recommend open up a blank folder, go across to data and use the get data Power Query functionality to access your CSV files and load them up that way. This is going to better pass the input than opening the CSV file from Excel directly. And it's going to visualize it better. So here's our 3 individual measurements and any details on that. And here's the average results of that particular Schmidt-Hammer file. So again, ideally, if we're doing any kind of visualization or opening raw data in Excel, you'll do a lot better to learn about and use Get Data Power Query than to just open a .csv file or open the direct export format from your NDT hardware, whether that's ProSec or another form or another device. Now you do have also available for further post-processing. GPR Insights is used to combine, visualize, annotate, export to CAD, and also do some other processes to your different forms of GPR data. And Pundit Vision is specifically about post-processing and combining ultrasonic pulse echo data from a Pundit PD8050 or PD8000, and also to produce what's called a phase analysis output. So on the picture here, that's the view from Pundit Vision software. It's primarily used to provide a second form of data analysis for void detection work, especially in the context of grouting conduits or grout tubes. And if we instead look at GPR Insights, this kind of augmented reality output is possible from Insights, but we can open the same data and process in GPR Insights. This particular case study is going to take that data and use the deterioration mapping process. What the deterioration mapping process will do is it will compare the intensity of the top layer of reinforcing reflections across the whole data set, which is just being reconfigured to be aligned correctly now. And that deterioration map will provide insight as to regions that might show more attenuation to that signal than other regions, which is a proxy for rust, moisture content, spalling damage, deterioration of reinforcing in that area. So just the post-processing output is able to detect as it works the particular position of the reinforcing as part of the deterioration mapping process. That's what the blue triangles that are visible, and when it produces a map, that's based upon the attenuation information. Now, DeFelsco equipment. I have always felt that DeFelsco equipment is the most flexible tool for producing a custom output report for coding inspection or for integrating into clever little bits of software or processes you come up with, because there are so many ways to interact with it. You have to simply collect your batch data log information. You can connect to a computer directly. There is Bluetooth synchronization to a phone application. There is also Wi-Fi upload to a cloud service of the data. So PosiSoft Desktop, that's the computer software. And that computer software is not just for review. The report format is very customizable, up to the point that you can overlay particular inputs on PDF files where that value would go. Very, very customizable. You also have slightly more esoteric integrations, like telling the device to output as if it was a keyboard the value measured with each measurement. So if you've got an industrial process where things are coming past an operator, they will be able to do that. And all of your images, file names, notes, pictures, and adjustments are controllable using the iOS or Android phone application as you work. So there's a lot of flexibility just in terms of data logging. And if you add to that, which I can't explain in too much detail because I simply haven't used them, there are developer modes which can stream data over Wi-Fi or otherwise provide inputs to more complex system integrations. There's a lot of flexibility available around the Defelsko product ranges. So we've got the application and the iPad application as well, and that keyboard mode functionality. The final little thing just to highlight before I close up today is what we can do with some of that raw data output. I showed just pulling information into Excel. We can do a chart. We can use those tools as well. This is work I completed with my partner many years, actually 4, 5, 6 years ago now, just to take half cell potential data and produce a software script that will produce the visualization output directly. It's the kind of skill set to produce this kind of process that I see as the missing link for engineers in particular, is if you're comfortable working with tools like this and taking raw data and having systems that will produce outputs like this, you'll be able to essentially automate some of your reporting processes, particularly around visualization and layout of your reports, and then essentially produce them in a way that removes that 12-hour word processing sort of process, is to start learning data visualization, data analytics tools, and working with those rather than staying confined to even a flexible tool like some of the Defelsko data outputs. So this is the conclusion of what I have to present formally today. I'd like to thank everyone for joining me as I wrap up and go into some question and answer.